Graham walks 8 blocks from his home to the library. He always walks 4 blocks east and 4 blocks south. So we've got to set this up. 1, 2, 3, 4. 1, 2, 3, 4. So where would his home be and where would the library be? Top left, home up there, because he walks from his home to the library. He got to go south and he has got to go east, so the library is down over here. Okay? Is that nice? Perfect. Okay. So what we could do is we could just start counting the different ways he could go. Can you see that he could go this way? 1. He could go this way. 2. Can you see we're going to run into a problem with our counting? If we just try to draw every single possible line as we went, because they would start to overlap and it might be hard to get there. Now inevitably, what he needs to do when he's walking from his home to his library, he's a smart guy. He doesn't get caught in a loop infinitely and get lost. He always gets closer and closer to the library. So would you agree that this is one possible route? And if I wanted to represent that route some way, I could say that this represents going south, 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 then east, 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 east. Now that's not the only way to go, because I could draw a different one in a different color. He could go like this, 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 and this. And if I write out that second one is east, east, then south, south, then east, east, then south, south. Easies. And when we start writing a couple of them down, we might realize that this is like a Mississippi question, because we have some identical objects in our letters, and normally then, if we think of it that way, there's 8 letters. Normally we would have 8 factorial, but if we divide out the repetition, that we have 4 E's and 4 S's, then whatever 8 factorial is divided by 4 factorial would be our answer. Someone have a calculator handy? Type that in. So how would you type that in? I would make a fraction, because I have 2 things on the bottom, otherwise I'd need brackets on the bottom. 8, hit the math button, over to probability, and the 4th one has the exclamation mark. Same thing on the bottom, although I find that in these questions you often have to type in like 2 factorial, 3 factorial, 4 factorial, and those are ones you can probably figure out. 2 factorial is 2, 3 factorial is 3 times 2 times 1 is just 6, 4 factorial is 24. So I might just go 24 times 24 on the bottom instead of going 4 factorial, because it saves me some time. Push enter, and we have 70 ways. So there's 70 different ways that he can walk home from the library. Okay? This is one method of solving this question. It is a good method because it's the reason it's embedded in this part of our notes, because it has identical objects. It's just written in a way that doesn't make you see that. Another strategy for solving this type of question is to start counting them in the following way. You start here. How many ways, if he wanted to get there, how many ways could he get there? How many paths? It's not a hard question. 1. That's the only way without looping back. Okay? If he went around and back, that would be not efficient. So assuming you're always choosing the most efficient way, there's only one way to get there. How many ways to get to this one? One. Okay? How many ways to get to this one? How many paths? Okay? It's 2 blocks, but how many pathways? 1. There's no other way to walk from here to here other than one way. Okay? Even though it's 2 blocks, it's only one way. Can you see that all of these ones along here will be 1? The only way, if you live in a straight line from something and you always want to go closer to home, you only have one route home. Same thing going down this way. 1, 1, 1. How many ways to get to this one? 2. How about this one? Can you see all 3 ways? Once this way, once this way, once that way. Similarly, this one will be 3. You might start to see a pattern. What do you think this number is going to be? 4. Okay, so this one's going to be 4 as well. That's not a bad pattern, but I want you to figure out the pattern. What's that number going to be? 6. How did you figure out it was 6? 3 plus 3? Yes. If there are 3 ways to get to this one and 3 ways to get to this one, you could get to this new one either by these 3 ways or those 3 ways, which makes 6 ways. And so now we see that you can find all of these numbers by just adding up the diagonal. 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5. This will be 15, this will be 20, this will be 15, 35, 35, and lo and behold, 70 ways to get to the library. Yes?
That would be like this
Yes. And the nice thing about this technique, if all of a sudden you wanted to add some restrictions to this, like sometimes there are swamps, I don't know, or alligator-infested swamps that you can't walk through. I was going to say a park, but a park's bad because people walk through parks, so we have to have, unless it's an alligator-infested park. Yeah. Then this strategy works really well instead of the south and the east, because there's certain places you wouldn't be able to walk through. Oh yeah, the questions you can do for this one are question number 12.